We struggled in class this morning with interpreting formulas that have one quantifier inside another. If any of you have taken calculus, you've actually run into this, perhaps without knowing it, when you saw the definition of a limit. Because the definition of a limit, if you were to write it out in our notation, would actually have one quantifier in another. It says that for every number there exists a number such that, etc., etc. What I've done here is I've taken a sentence we were working with in class this morning, and I've stripped it down to a simpler interpretation where we've only got two objects, and it's a little easier to see what's going on. So, what does this sentence say about this interpretation? First, the point about the interpretation. When we have quantifiers, we're saying for all or for some about some particular domain. It's sometimes implicit. It's sometimes explicit. It might be implicitly the students in the class or implicitly the counting numbers, or we might do what we do here, spell it out explicitly. We also have to say what the predicates, in this case F and G, mean, and we've done that. So, this sentence is saying that every object X in the domain fits this description. Every member X of the domain fits this description. Now that means that A fits this description and B fits this description. So far then, that's what our quantified sentence says about this domain. If there were more members in the domain, if we also had C, we'd add an extra conjunct where we'd have a C here instead of a B or an A. For this sentence to be true, in other words, this has to be true and this has to be true. Let's look at those in turn. What does this say? Well, this says that at least one member of our domain, at least one y in our domain, fits this description. We use a different variable because it may or may not be the same thing as the thing on the left. The y here doesn't have to be A. It could be something different. So using different variables allows us to get that possibility in without it getting lost in having only a single variable to work with. So, if at least one thing in the domain fits this description, at least one thing y fits this description, that means either A fits this description or B fits this description. That's what our first conjunct is telling us. The second conjunct is telling us something similar. It's saying that at least one object y fits this slightly different description. That means that either the object A fits this description or the object B fits this description. Now, what is it that makes the two descriptions different? Well, it's the fact that we've got an FA here in the first conjunct and an FB here in the second. But at this point we can go ahead and we can evaluate. We can decide, is this sentence true or not? If it's true, our original quantified formula is true in this interpretation. If it's not, our quantified formula isn't true. So let's check. FA if and only if GA. Well, A is an F and G is not. So this is false. FA if and only if GB. A is an F, B is a G. Therefore, we'll put the 1 here now. The OR statement is going to be true because it has at least one true part, namely, in this case, this one. So we've got an AND statement that has at least one true part. Now we go on and look at the rest of it. FB if and only if GA. Is that true? Well, B is not an F, but A is not a G. Both sides of the double arrow are false, which makes the double arrow statement true. And that already tells us that the OR statement is true before we even bother to worry about FB if and only if GB. So that means our AND statement is true. Our AND statement is true, and so our original universal statement is true. The point of going through this exercise here is to spell out in a way that lets you really understand the internal workings of this, what our sentence means. This is called a truth functional expansion, and that's discussed in the text. We don't always bother to use truth functional expansions, but whenever you have a finite domain, you can always do it. So first, make sure that you have a good grip on this. This statement really is true, and the truth functional expansion goes through the process of figuring out what it says about this interpretation. But now let's flip the order. We'll keep the same interpretation, the same domain, the same meanings for F and G, but we'll flip the quantifier order. And now we'll ask, what about this sentence? Is this sentence true? Well, this sentence says at least one member of our domain Y, that is to say either A or B, fits this description. At least one thing in our domain Y fits this description. That is to say either A fits this description or B fits this description. For our sentence to be true, one or both of the disjuncts has to be true. Now we can go and look at the disjuncts. What about this? What does it mean for this to be true? Well, this means that every object X in our domain fits this description. That is to say, A fits this description and B fits this description. What about our second disjunct? It's going to be very similar, as you can see. For this to be true is for every object X in the domain to fit this description. That is to say, A must fit this description and B must fit this description. So now we can go about the business of seeing if this sentence is true. For this domain with these objects, this sentence spells out what this is telling us. Let's look then. FA, if and only if GA. Well, A is an F, but G isn't. So we have a false here. And that already tells us, before we go any further, that this AND statement is false. We don't even need to check the remaining conjunct. So it all depends on this second bracketed expression. FA if and only if GB. Well, that's true. FA if and only if GB is true. So far so good. We have a true here. But the statement in these square brackets is a conjunction, so we have to look at the rest of it. FB if and only if GB. Well, B is not an F, but B is a G. And so we're going to have a false here because this part is going to be false. That means we have a false here, we have a false here, and our OR statement is false. So this statement, which we spelled out in 2 steps for this interpretation, turns out to be false. Now, we don't always bother to write out the whole truth functional expansion, but if you're stuck and if the domain is finite, you can always do that. More to the point, if you think about how we get to this point, you'll be understanding better what it is that quantified statements like this mean. So I commend this example to you. You could listen to the lecture again. You could also slightly complicate or change the interpretation. You might add an object. You might change the meanings of F and or G and see what comes out. but I strongly recommend that you do play with it in that way, and you'll start to get a feel for how this works. It can be, no doubt about it, tricky in some cases, but it is manageable.